So I found this balance in the Inspiration software, little graphics. They have libraries of graphics. Just to indicate that the equal, we're going to think of the equal sign as the center part of the balance. And we don't have it up now, but what Mrs. Deers, my mentor teacher, had done the previous day, she had an applet which showed a balance that you just put shapes of varying weights on each side. And so you might have 5 shapes of different colors on one side and maybe 3 shapes on the other, but they balanced. And then she could take one off with her smartboard, just using her fingers. She could take one off, and whatever she did to one side, she had to do to the other to keep the balance. And then when she added a shape, she had to add the same exact shape to keep the balance. So again, we demonstrated that whole idea of it's not about the amount of objects on each side of the equation, it's about the value. And we kept emphasizing that. She had taught the day before, and I was following up. Okay. So I followed up with, she had done addition and subtraction the day before, and I was doing multiplication and division. So we talked about what operation is between the 7 and the x. And, of course, the kids knew that it was multiplication. We also emphasized that now that they were in 6th grade and they were learning real algebra, that we now write the number, when a number is written with a variable indicating multiplication, we do not write the little cross multiplication sign anymore, because that notation gets confusing to have a little x meaning multiplication and then you have an x variable. So we just now put them together, and we really went over, this is the way you do it now. So that was one thing that I've noticed with 6th grade mathematics, is that transition from what they've done for 5 years in elementary school and now saying that was elementary school and those were correct concepts, but now we're becoming more fluent in math, and we're using more advanced notation. So, and they seem to like the idea that they're getting to learn more advanced notation. That makes them feel smarter. So we talked about, okay, if 7 is multiplied to x, what's the inverse operation of multiplication? And they just knew it was division. So I said, okay, we're going to divide. Now, which number are we going to divide by? And some students would accidentally say 14, which gave us the opportunity to continue to emphasize the point, we're solving for x.
It's just not calibrated. It's just not calibrated.
Is that it? X. We're solving for that. Got it.
Yep.
And so we use the number that's on the same side of the balance, or the same side of the equation, as the variable. And so they said, okay, well then we would divide by 7. And that's correct. We talked about how when 7 divided by 7 is 1, and how 1 is the identity in multiplication and division, that 1 times anything is itself, and that's why we're allowed to cancel this out, and we get 1x, which is actually x. And so then we solved on this side, keeping the equal sign, to 2, x equals 2, and then we circled it because we wanted them to get into the habit of always circling their solution. So they were very open to that and very good with that. Okay. This was the hardest operation for the kids to get, and the reason is because they know that the 7 is in the denominator. They see that. They understand that this represents division. They understand that the inverse operation of division is multiplication. However, they want to put the 7 right there when they multiply. And then this confuses them because they know they can exit out, but they're not showing conceptually correct math. Because that's really x over 49 is what they're showing, but they think they're doing it right. So we had to go over several of these. And I told them that what you're doing is you're multiplying by a whole number. So we're going to keep 7 up in the numerator. Sorry that this isn't just right. We're going to keep 7 up there. That enables us then to be able to cancel, because 7 is now over 7 again, and 1 times x is x. Whatever we do to one side, we do to the other. So we have x equals 4. 14.
Okay.
Circle it.